Switches are really important components in a circuit. We need to control the electricity. Switches do that for us. So let's have a look at a variety of switches, starting with this one. And this is really sort of a demonstration switch. It's not a real switch that you would ever use at home or in an electrical gadget, simply because lots of the metal is exposed. And if this was at home for a switch and somebody was to touch it, then in theory they could be electrocuted. So bare wires are a bad idea at home, but this is a good demonstration switch. And when you open it up, it's got this lever. So it's got a mechanical lever, and this is made of metal and the plastic tip there to hold, and then it touches another piece of metal. Now plastic isn't the only thing here isn't just the tip that's made of plastic. The whole body is made of plastic. So when you think about it, if this was in an electrical circuit, the electrical connection can't be made to the plastic. Its job is not to let electricity travel through. The electrical connections in this circuit are made, electrical wires can be attached underneath, look, are made to these metal parts, the central part here, and there's a little connection there we can use, look, and to the part that's separated from it, and you may just be able to see there's a tiny gap there. So in order for electricity to be able to travel from this part to this part, that switch needs to be put into that position where the metal from the lever can touch the metal on the other side. It's a bit like bridging a gap, isn't it? Bridging a gap. So we could use our electrical connections from this side and then from the other side there and put that into a circuit and it would work. So let's have a look at more common type of switch. Look, this one, and we'll open this one up to have a look. There are the normal electrical connections that I've been using in the little demonstrations so far. Let's open this switch up and have a look. And as you can see, it's got a metal lever, and the lever's touching underneath there. You just see it. The lever's touching against another piece of metal, and that happens to be a sort of curved piece. And as the lever moves this time, it's actually pressing down on that curved piece of metal. And it looks very much like a shiny orangey brown piece of copper to me. So I'll turn it sideways and then we'll operate it and just have a close look at that electrical connection. Let's have a look. I'll just try and zoom this up a little bit. You can get a very close look at that connection. So there's the little electrical connection there. There it is, there's a gap in it there. I'll try it from a few different angles. So when we operate the lever, it simply makes that springy piece of metal, copper metal, move up or down. And when it's in its down position that way, it touches a piece that remains still. So it's got a moving piece of metal. So the moving piece is attached to the lever, and then a fixed piece which is attached to the one of the electrical connections we make to the switch. So there it is there, moving in and out, in and out. So when the electricity travels in from one end of the electrical circuit, it can travel through the switch only when that gap is closed, and for that to happen, the lever has to be tipped over, pulled to one side, and then the electricity can travel through the rest of our circuit. Very important to mention, the whole thing would not work if it wasn't for the plastic material which is keeping these electrical parts in the right place but apart from each other. So folks often, miss out the plastic. The plastic is just as important as the metal. The metal's doing its job, and the plastic is doing its job. The plastic's doing its job of keeping the materials all in the right places. They're fixed into the plastic, but the plastic itself does not let the electricity travel through. It's only the metal that can do that when the switch is operated. So these two switches are really very similar to each other, except this is just a big open version of this, and this has got like a springy action to it rather than that sort of big long lever action there. So switches, all of these switches are made of the same parts but in different shapes. Metal connections, a plastic material to hold all the connections together, and this one's got a plastic sort of lever button on the end, and it slides left and right, and as it slides left and right it's able to complete electrical connections inside to those contacts, or push it the other way, or to those contacts. So this is really several switches in one. There's a miniature version of that, and there's a different type of switch. Instead of sliding, instead of making a lever rock left and right, this type of switch rocks in a slightly different way, one side or the other. These are very common on devices where you see a 0 and a 1 for on and off, and there's our electrical connections underneath. So switches are in all different shapes and sizes. I wonder if we can make switches if we've got similar materials. So if we've got metals, yes we have. If we've got electrical wires to link things together, well yes we have. If we've got a way of holding the metals in position but allowing them to touch or not touch, yes we have, then we can make our own switches. And if you do test enough materials to find out which ones allow electricity to travel through, you'll see that silver foil. Now we shouldn't really call it silver paper. Silver foil, it's a metal foil. That can be used in our circuits as well, as can paper clips. And instead of this plastic foam, which is the insulator, of course we could use just ordinary card. A piece of card can take the job of the insulator. Okay, next video will be designing our own switches.